Welcome to my YouTube channel Math Academy for CSIR Net. Just solve every question in 20 seconds and shortcut note for the problem solving question. And today's topic is linear algebra. Here first question is let n greater than equal to 1 and let A be any n by n matrix with real entities such that a to the power k is equal to 0 for some k greater than equal to 1 and let I be the identity matrix whose order is n by n, then which of the following option is true? So if I take the value of k is 1, then A is a 0 matrix, so I plus A imply is the only I means identity matrix, so determinant of I is 1. So first option says I plus A need not be invertible, so determinant is 1, so this matrix is invertible, but option A is false. Determinant, option B, determinant I plus A can be any non-zero real number. Here option says that any, but here determinant of I plus A is 1, so this is only value of the determinant is 1, so option B is also false. Option C is determinant of I plus A is equal to 1. Here option C is true since determinant of I plus A is 1. And option D is a to the power n is a non-zero matrix. Since n is the order of the matrix, so the characteristic polynomial is x to the power n equal to 0, and by Cayley-Hamilton theorem every matrix satisfies its characteristic polynomial, so a to the power n is 0, so here a to the power n is always 0 matrix, so here option D says that a to the power n is a non-zero matrix, so option D is false. In another, if I take value of k is 2, then a square equal to 0 for this matrix. If I take 0 1 0 0, whose order is 2 by 2, and for this if you check I plus A 1 1 0 1, so whose determinant is also 1, hence option C is always true. And question number 2 is let A be a n by n matrix each of whose element is 1, then which of the following option is true? Let A be a n by n matrix whose each element is 1, so obviously rank of A is 1 and trace of A is n, means sum of whose diagonal elements. So here number of 1 is sum at n times, so trace of the A is n, and this is by result if the rank of a matrix is 1, rank of a matrix A is 1, then eigenvalue of A is trace of A, and the remaining all eigenvalues are 0. Here since order of the matrix A is n by n, so 0 means n minus 1 times eigenvalues of A is 0, and only one eigenvalue of the matrix is trace A. Here trace A means n, so eigenvalues of A is n and remaining n minus 1 eigenvalues is 0. And this is also by result if a matrix whose rank is 1, rank of the matrix is 1, and also trace of the matrix is non-zero. Here trace of the matrix is n, which is non-zero, then this matrix is diagonalizable. This is by result. So always remember this result. If a rank of the matrix is 1, then whose eigenvalues is trace A and the remaining n minus 1 eigenvalues is 0, and this is result 1 and this is result 2. If the rank of the matrix is 1 and trace is non-zero, means n, so then imply A is diagonalizable matrix. But here third result is, if rank of the matrix is 1 but trace 0, then this matrix A is not diagonalizable. Always remember this result. This result will help you to problem solve in CS and NET mathematics easily. So this is by result. A is diagonalizable matrix, and we know that theorem, result 4. A matrix A is diagonalizable if and only if its minimal polynomial contain linear distinct factor. So A is diagonalizable if and only if its minimal polynomial contains linear distinct factors. And we know that every minimal polynomial contain the eigenvalues. Clear? This is first result. Number 5 result, every minimal polynomial contains every eigenvalues. Clear? So by the result 4, A is diagonalizable since here trace is non-zero, so A is diagonalizable. For this question number 2, since here says that A is a matrix whose all elements is 1, so rank of the A matrix is 1, so this matrix is diagonalizable. So for this diagonalizables, by using the result 4, is diagonalizable if and only if its minimal polynomial contains linear distinct factors. So its minimal polynomial is here the first factor. If I take the eigenvalues here, since eigenvalues of A is n and the remaining are 0, so x minus n is one factor and another factor is x. Since is linear distinct factor, so only x is, so this minimal polynomial is x square minus nx. Hence option D is true. Option C is not true because this matrix trace is non-zero and rank of the matrix A is 1, so this matrix always diagonalizable, so option C is false. Option B is also false, and option A is a very good result. If a matrix A, here A matrix is diagonalizable, so if a matrix is diagonalizable, then the number of Jordan block is always equal to the order of the matrix, but here says that not, so option A is also false. अगर आपको सबको मेरे वीडियो अच्छा लगे तो प्लीज़ लाइक, शेयर एंड सब्सक्राइब माय चैनल्स, एंड द remaining part of sorting notes of linear algebra I will upload next videos. Please stay connected with my YouTube channel and share with friends for sorting notes and every problem solved in exam hall just 20 seconds. Thank you.